Here I have the C program written in SimpleIDE for the Parallax Propeller board weather station I was creating. Here I'm initializing the SD card pins so that I could write the data onto a text file onto an SD card. Right here I'm initializing a few counts that I'm going to use later to keep track of where I'm going in my program, how many times I'm collecting data, how to wait for 30 minutes. This initial count right here is actually because I sample 3 times and then average the samples for each data point written to the SD card. That way I get a little bit more accurate of a reading than if I had just done it once and closed up the program. So here, this is some functions that are associated with the CM2302 library that I downloaded off of GitHub. Added them in there. So this will actually store, or I'm sorry, this will store the temperature and humidity into an array, at which point I will average the array, and then I have some print statements right here to show that everything's functioning properly and that I'm getting not such ridiculous numbers are popping up. I've actually commented out a few of them because I've gone through it so many times. This will open up, after averaging, this will open up the text file, write the data to it, and then close it up. Here, this will wait for 30 minutes. So using the wait count function on the internal crystal clock that is working there, you only get about less than 60 seconds. I think it's 52 seconds before the register will overflow. So what I've done is I've just waited 30 seconds and then you increment a counter, and then after 60 30-second counts, and then it's time to go back through the program and you'll cycle through all this again, create new arrays, average the values, write it to the SD card, and then we'll go back and wait. One problem with this program, which I thought about after I'd ran it, is that there's actually a 6-second additional time amount that I did not calculate here with this pause function here. This waits 2 seconds in between each reading. That's just so the sensor can reinitialize, and that's actually very necessary to wait that 2 seconds. Plus, there's also the actual time it takes for the computer or for the microcontroller to execute the instructions, which I haven't accounted for. So what I would really need to do is add, figure out, well, obviously the 6 seconds isn't that hard. I could just say, every couple of days or whatever, count one less time, one less 30-minute time, and I don't really care if my temperature data is taken at 12:01 rather than at 12, because I mean the temperature and the humidity haven't drastically changed in 1 minute. But I do care that after 2-3 weeks or whatever, I'm 10-15 minutes off, then I'm really not getting the data I'm looking for. So what I would need to do is figure out the actual processing time it took to run the whole program, and then add my pauses in there, and then take that into account and add another stipulation to this before this wait count variable here, so that every now and then, like this would probably be changed to a variable, and then I'd have 2 separate variables, and it's like, oh, every 15 times, only wait 58 times or 59 times or something like that, and that would actually reset my clock. Another option would obviously be to buy a separate clock that has a much more accurate time crystal, something that I could hook up and would keep the time more accurate than just Parallax board. But for what it's worth, this is fine for right now. It's proof of concept, and it wouldn't be too difficult to figure out how to reset that time counter more accurately than I have it right now. So here I have my little portable weather station I've built out of the CM2302 temperature and humidity sensor on a Parallax Propeller activity board. If you go on the website, there's a temperature and humidity introduction, and they have the circuit diagram on there. It's a very simple circuit, just a 10K resistor going in parallel from 3.3 volt power to the sensor, and then a pin 5 telling the sensor when to go high and to actually read a temperature and humidity, and then just all connects to ground. Sorry about the light here. In there I have a little battery pack, so this is nice and portable. Sorry about the camera work here. I did the clock speed, I did RC slow, which you can go into the configuration files in the Parallax board, and you can change that so that the clock's running at a much slower rate than the normal 80 megahertz, and this will give you drastically more battery life. So I'm going to run this for 2 days for proof of concept, and then I'll run it in my room after that, just see how long the batteries last on there. If I get to a couple months, I'll probably just turn it off, but for now, this is it. Portable weather station. So here's the box outside, taking the temperature now, hanging out next to my buddy Bones, the skeleton dog. It's Tuesday, 5 o'clock, January 7th, 2020, and we'll come back in a couple days and check the data out. Alright, so here I have the MATLAB program to plot the data from my weather machine outside. So this function right here will import the data from the text file into a matrix, and this will split into two arrays, temperature and humidity. This will create a for loop right here that will calculate the dew point from the temperature and humidity. This right here will give you the timestamps. So from time 1, 2 days later, time 2, when I ended the data capture, and then this will increment each plot point by 30 minutes. This right here will actually plot the data. So I have temperature, humidity, and dew point plotted. R, B circle dash, G star dash, or just, this will be red, blue, green, and this will have like a little circle, and this will have a star instead of just being a line, and the red will just be a red line for temperature. This will give me a label for the date and time. I have my temperature, humidity, and dew point all on the same y-axis, and then this will give me an x limit on the graph from the initial time to the final time, and then this will give me a y limit somewhere in between my minimum and maximum values that will be present on the graph. This seems like a good choice right here, since the humidity is pretty high and the temperature is pretty low. This right here will create tick marks. So you'll start at the very first element of array T, and then every 8 elements of T, you'll create a new tick mark. You'll do that all the way to the end. This will be for the x-axis. And then you go x ticks here, and then that will create like a little 45-degree angle for the tick mark, I guess, titles. And this will create a legend in the final graph. So I click run here. See, I already did it over here a couple times. But this will open up a figure. And here's the figure window. So as you can see, I didn't let it acclimate outside when I turned it on for the first time for enough time. So we have our first capture has a really high temperature that it never goes back up to, even at our highs here, which were a bit warmer of a day than the first day we had it outside. So this was a mistake. I should let this sit outside for maybe an hour before I turned it on for the first time. As you can see, the temperature and the dew point kind of follow each other pretty well here, which I guess makes sense because it's dew point temperature. It should be usually slightly less unless it's actually raining. It gets incredibly close to each other. As you can see, the higher the humidity, the closer the dew point and the lines of the temperature are to each other. I think that's how that works. I'm not a meteorologist, but I believe that's how that goes. Humidity seems relatively constant. It was pretty humid those days, very overcasty. So yeah, that's the final project. Take these text files, check it open here, and just, it's a number. The first value is the temperature, second value is the humidity, and then, you import them, plot them up, and that's all you need.